Hi guys, we are back. So let's now complete a square on this business. So on the generic formula of the quadratic equation, we have ax squared plus bx plus c is equal to 0. Let's now complete a square on that and see what we get. So the value of a, we will have to divide by it. We can divide by it in this case. Why? Because it's an equation. Divide by that. After dividing by that, we'll have to take this term over here, the coefficient of x, divide it by 2 and square it. Take that, we divide it by 2 and we're squaring it. So now if we take that and we add it over there and we subtract it over there, we have this guy over here, which we can write as a perfect square, which is this business over here. You can see we are writing it as a perfect square. This guy over here, we can, we can add or subtract, whatever you think about it, but basically the process would be finding a lowest common denominator, which is for a squared, and adding these two things, so we get that term. We can get that term to the other side. We take that term to the other side, this is what we get. We can take square root both sides, this is what we get. Now we can take b to the other side, that's what we get. We can again find the lowest common denominator, which is 2a, and we add those things, and that's what we get. So we have our roots, guys, pay attention to this part. We have our roots being x, it's equal to that, or x, it's equal to that. And I'm saying pay attention to that part because I think I've seen a question that forces you to, it's not forcing you, but it's asking you to write these roots. So now, if we take a traditional form of the quadratic equation and we complete a square on it, we get a quadratic formula, right? That's a quadratic formula. It's at the back of your answer sheet. So from going through this process, someone sat down, remember this process was us completing a square to solve that business. So now what we can do, we can just plug and go, plug it in the formula and go, and so now what we're looking at here is that someone sat down and came with how we can generalize completing a square in order to find roots. That's pretty amazing if you ask me. Now, it is important that you have a square root there, so b squared minus 4ac must always be greater than 0. If it's less than 0, you have imaginary roots, of which we don't talk about in our syllabus. So now, it's going to be easy. We're going to solve quadratic equation using a formula. What? That's amazing. So what do? If you have something like that, you must identify your A, your B, and your C. But again, you must always put it in standard form. If you just took that, that would have been positive, and I'm not sure if you will be able to call it C. But the point is, put your stuff in a standard form. Then identify A, B, and C. You can see where they are identified. Plug in the formula, right? Write the formula and plug in the formula. Simplify a bit, guys, that's important. You get a mark for that. Simplify a bit. After simplifying a bit, that's what you get, and you are done. Okay, obviously you can put that in a calculator and simplify it a bit. Again, you can have that function f of x equal to x squared minus 5x plus 8. Try to find roots there. Identify your A, your B, and your C. Plug and go, and that's really how it is. So you can see over there that you have a square root of a negative something. Your calculator will pop an error like, oh, an error, you don't know why, you might not know why it gives you an error. That would be the reason. If that's the case, if you see that's what's happening, then you should understand why it gives you an error. And basically this is what it means: the graph is above the x-axis, so there's no way that the graph is cutting the x-axis. So that's why you don't have roots. You kind of do have roots, and they're imaginary roots. But let me quickly check how much time do I have. Okay, I think we can go again. Yes, you actually have roots, it's just that they are imaginary roots. So let's go look at this parabola, how it looks like. Ooh, this is fun. Let me see if I can just copy that and paste it on Google. I doubt I'll be able to, otherwise I will just search something that's gonna help us to look at what's happening here. Ooh. Ba, ba, ba. Let's see if it's gonna work out. Guys, do you see how quickly you can just grab something and put it on Google? Okay, this is not really helping. Let me see if I say imaginary roots of a parabola. I want to show you how this graph looks, and I saw some nice graph long time ago when I was looking at this. That was long time ago. Okay, cool. Yes, that's the picture. Cool. So basically you can see on the y-x plane, your function goes exactly there and it doesn't cut the x-axis. But you can see the imaginary plane coming out of the page, and your parabola actually go and do what you're seeing there, and you actually do have roots in actual fact, but they are not in the x-plane or x-axis, they are in the imaginary plane, right? So that's really what's happening there. So your actual function is like that, but this function, if you look at it as a surface, it actually comes and intersects the imaginary plane. So, and that's it, guys. If you want more problems, as I scroll down, you can capture these problems and start doing them. I don't mind if you find any problem anywhere you ask me, I'll definitely help you out. So guys, that's it about solving quadratic equations using the quadratic formula. So I'll see you in the next video. Probably we'll be looking at case substitution. Thank you, guys.